Hello friends, so this is part 2 of my review of factoring. So in this video we're going to talk about grouping and the sum and difference of cubes. So the way I kind of separate my series on a factoring review, so I start with the GCF and basic trinomials. So in the first video we talked about things that maybe you'd be more likely to remember, and these are things that are like quicker to pick up. In part 2, so grouping and sum and difference of cubes. So these are two topics that almost everybody seems to forget are a thing, but they're not too bad. And then in part 3, I'm going to talk about more tricks and algorithms and other things that you can use. So by the end of this, hopefully you've got a pretty good grasp on factoring. And if you don't, I have longer videos on any one of these topics. So this is like literally just meant to be, a review if you're coming back to factoring. Okay, so let's start by talking about grouping. So we're going to start by factoring this ax plus ay plus bx plus by. So this is like your classic grouping example. So what I want to point out here is that, so we've got 4 terms, but there's no GCF. So, and at this point, right, you should know what the GCF means. So we've got a's and x's and b's, and y's, but no terms share the same, one thing. So when you have 4 terms but no GCF, this is often screaming for you to try grouping. That's the hint that you might want to use it. So let's talk about how to actually do this then. So this is your classic grouping example. So what I'm going to want to do is I'm going to say, okay, in the first 2 terms, I notice that both of them have an a in common. So what I'm going to do is I'm going to factor out that a. And then in the second 2 terms, I say, oh, they've both got a b in common. So I'm going to factor out the b. Okay, and then now notice, so forget about this line for a second. Just let your eyes look at this. So check this out. I effectively now have this is a term and this is a term. And what is the GCF of this thing? The x and the y, right? So this x plus y and this x plus y, I can factor that out. So if I factor out x plus y, what am I left with? I'm just left with the a plus the b. So there's a couple different ways that you can kind of think about this. You can either think to yourself, well, if these 2 things are the same, then I just take the terms in front. Or you can think about this as I'm actually factoring out the entirety of this x plus y. And when I divide out the x plus y, I'm left with the a plus the b. So there's 2 different ways that you can think about why this works. This is the idea of grouping, and it is like a 2-step process. Now, at this moment, I want to just remind you of how to get the most out of this video. These videos are not intended, I go through them, but I intend for you to pause and write things down and try things yourself. Math is not a spectator sport, and you are never going to learn it by just watching a video. You do actually need to pause any math video and try the things on your own to get the most out of them. So that being said, let's try some of these examples together, and just pause the video when you need to write things down, just a reminder on that. Okay, so for this first set of examples, I just want to finish the grouping so we're kind of like used to this because it can feel a little awkward at first. So I've got this x minus 2y, so this is x minus 2y, this is x minus 2y. Doesn't matter where you want to write the x minus 2y, but I usually like to write it first, and then I just take the terms that are in front. 5 and plus z squared. So I just take whatever symbol's in front. So I'm left with 5 plus z squared. Now, what if I wanted to write this? Tomato, tomato, doesn't matter which way you want to write it. These are the same thing. All good, but that's how you would finish the grouping. Okay, so with that in mind, why don't you try to finish the grouping here? Hit pause, hit play when you're ready. Okay, so in this case, I've got a minus here with no number. And so you have to just kind of know then that there is an invisible 1 right here. So to factor this, this becomes 6x squared minus 1 and 3y minus c. Or again, so I'm not going to keep repeating this, but I'll write this down one more time just to make it clear. You can write it either one of these ways. So going forward, either way is totally fine. Okay, so now let's try grouping on our own. So I've got this example here. If you feel comfortable with this, you could always just try to see if you can do the whole thing on your own. Otherwise, I'll go through it with you and you can try the next one. Okay, so same idea here, right? So I look at the first 2 terms and I say, okay, what do they have in common, or what's the GCF of the first 2 terms? So in this case, that's going to be 4x. So then I can factor this out as x squared minus y. And then in the second two terms, so let's see, what did these have? Oops, I'm sorry, I made a mistake there. This is x squared, sorry, this is 3y, my bad. And then for the second two terms, this will be, looks like they have a y in common, so this will be x squared minus 3y when I factor out that y. And now I have got same thing here, so I can go ahead and finish this. So this will become 4x plus y, x squared minus 3y, bada bing, bada boom, we're good. Okay, cool. So why don't you try this one totally on your own? Pause the video, give it a go, hit play when you're ready. Okay, so in the first two terms, I'm going to factor out x, so this becomes y plus 4. The second two terms, they both have a minus in common, so it's up to you. I'm just going to leave the minus sign here. Okay, so here's the thing that is kind of tricky with this. Make sure you factor the minus out of both terms. So sometimes what I'll notice happens is someone will factor out the minus out of the first term, but forget in the second term. So that would be incorrect, and then we wouldn't be able to finish the grouping. So I have to take out the minus from both terms, and now this allows me to finish the grouping. So this is very similar to an example that we just had, right, where I didn't have anything in front of the minus or behind the minus. But this will factor x minus 1 and y plus 4. Okay, now if you want to see more examples of that, I do have more examples, so feel free to check out the video library. But what I want to talk about now is I want to talk about one more type of grouping example where maybe it doesn't look like grouping is going to work. Okay, so let's start with this example here. So once again, no GCF. And it looks like grouping. So I'm going to just show you what happens. And remember, pause and write things down if you feel that you need to, or you can always double back and write things down or whatever you need to do, but make this video work for you. Okay, so I'm just going to jump to like the steps that I do. So I factor out 3 from the first two terms, and then I factor out 2x from the second two terms. And so here's the problem. This is 4x squared minus 5y, and this is 9 minus 5y. So what's the issue here? These are not the same. I cannot group this if these are not the same, so I cannot finish the factoring. So what do you do when that happens? You don't want to throw in the towel quite yet. You might say, all right, great, it's prime. No, it's not prime. Hold on. So instead, before we jump to it's got to be prime, try to reorder. So maybe this just wasn't set up in the best way for the grouping. This can happen. So if I try to reorder it, I'm just going to take a stab in the dark here as to like how to reorder it. So what I'm going to do is I'm going to put the 12x squared and the 18x together, and then I'm going to put the things that have y's together. Okay, and so now if I group this, so now out of the first two terms, I can factor out the 6x, and out of the second two terms, I can factor out the negative 5y. So notice then that when I factored this out, both of these became positive. And then, okay, this actually does work. Now, 2x plus 3 and 3 plus 2x, those are literally the same thing, right? So 2x plus 3 equals 3 plus 2x. So you have to kind of think about this sometimes. They might look different, but they are equivalent to one another. So this is all good. I can finish. We're all happy. Cool. Okay, so that's grouping. So like I said, if you need more examples, just check out the video library. I've got lots of examples on this. Or if you want a longer explanation on this, I even have like a full lesson video. So if this was too fast for you, then, make it work for you. That's kind of the beauty of the online learning, right? Okay, so next I want to review sum and difference of cubes. So this is like my least favorite type of factoring, only because it actually requires you to remember a formula. I try not to make you remember formulas as much as possible because it's just too much. I like to remember concepts over formulas. A lot of books will talk about, oh, remember this formula, remember this formula. You usually don't need to do that, but with sum and difference of cubes, it's actually the only way you can do it. Here are the two formulas. So this would be, the first one, this is the difference of cubes, this is the sum of cubes, and these are the formulas associated with them. So you are going to want to pause the video and write these down. And then, maybe just pause right here and do that. So, okay, I know that when you write them down, it looks kind of intimidating, but they're actually very similar formulas. So I want to appreciate this before we go any farther. So, a cubed minus b cubed. So I just take a minus b. So I start with the same sign, and then a squared plus ab plus b squared. Okay. And then a cubed plus b cubed. Now you go a plus b, and then you do this. So the things that I like the things that help me remember this, these are the same signs, right? So this and this is the same sign, this and this is the same sign, and then this sign here will be the opposite of whatever's here. So what I find with the sum and difference of cubes is that usually a lot of students have to just straight up write down what the formula is before they use it. So don't be afraid to do that, but you are going to have to memorize this for really a lot of math classes. This can kind of like pop up. All right, so let's talk about how do we actually use this then. So here's a great example. So I've got x cubed plus 8. So the key to this is, so one, we want to write down the formula that we want to use. So let's do that. So this is a sum, this is a cube, this is a cube. So what I need to do is I need to identify like what is my A and what is my B. So what I find helpful for this is usually I say, okay, first identify what's in the A cubed position. So what's in the A cubed position is x cubed. And so then what does that mean that A must equal? So then A must equal x, okay? Then what's in the B cubed position? In the B cubed position is an 8. So what that means then is what must my B equal? Well, my B must equal 2. Now, what if you didn't know that? So here's just a quick little reference sheet of cubes. You can pause and write them down if you want, just in case you forgot what some of them are. So 2 cubed is equal to 8. So you have to know what the cube form of that number is. So 8 is 2 cubed, so therefore my B is equal to 2. Again, pause this and write it down should you want to. Okay. So now that I have this, so I really needed this piece of information and this piece of information. And now literally just where I see an A, I'm going to replace it with an X, and where I see a B, I'm going to replace it with a 2. So I'd actually encourage you to pause the video and just take a second to do that at your own pace before you watch me do it. Okay, so the way that this is going to factor then, this will factor x plus 2, x squared minus 2x plus 2 squared, and you're going to want to rewrite any number that is being squared. You do want to rewrite it in its non-squared form. So 2 squared is 4. So you're going to want to write it like so. Okay, so that is the idea behind this. So I have another one for you. I strongly recommend that you pause the video, do this at your own pace, hit play when you're ready. Okay, so in this case, I need to use the difference of cubes formula, so I'm going to write that down. And then I just need to identify like what is where, right? So in the A cubed position, I have the y cubed, which means that my A is equal to y. And then what's in the B cubed position is a 1. So then my B is going to be just equal to 1. And I will do one more time, just if you want to pause and write this down, if now you're like, oh, I really need that, so you can pause and write that down. Okay, so there's everything. So if I fill this in, this is y minus 1, y squared plus y plus 1. There's everything factored out. Okay, so here is this last one. It's definitely a little tricky, but you know, it's good to challenge yourself. So these are both cubes. I think you can do this one. Pause, try. Remember, math is not a spectator sport. And the worst thing that happens is you get it wrong and then you learn something. You're more likely to remember and learn something if you make a mistake and then learn how to correct it versus if I just show you how to do it perfectly every single time. Pause, hit play when you're ready. Okay, so the formula that I want to use this time is this one right here. And I hope now you're kind of seeing like this, like writing this down, if this is helpful to you, just do it. And like if you're doing like a quiz or a test or whatever, like the more you write this down, the more you're likely to remember it, and you're going to make it a lot easier on your brain as to like, what are we trying to do here? So I'm really a big fan of you writing this down every single time, and especially like on tests and stuff. Okay, so now in my A cubed position, I have this 8x cubed, and it looks a little intimidating, but the thing is, so I know that 8 is 2 cubed. So if I'm just looking for what is the A version of this would just be 2x, right? So 8 is a cube because of 2, x is a cube because of x, so this is going to be what's in my A position. And then in my B cubed position, I have this 27y cubed, which means that my B will be 3y. Okay, so now let's factor this. 2x plus 3y. This one's going to be a little tricky. So I need to square all of 2x, and then I need to multiply 2x and 3y together, and then 3y squared. Okay, here's everything that needs to happen. So you need to square the entirety of 2x. So this was a trickier problem, and if you missed that, if you got kind of some of this, that's pretty good. But you do need to square all of this. So when all is said and done, oops, sorry about that. Sometimes my tablet goes crazy on me. Okay, so 2 squared is 4, x squared is x squared. So this becomes 4x squared. Okay, 2x times 3y is going to give me 6xy. And then 3y squared, so 3 squared is 9, so this becomes 9y squared. So notice when I square the entirety of it, I square the number and the variable. So here is everything now in its lovely factored form. Okay, so I do have more videos with examples of all of that should you need them. If you found this one helpful, consider hitting the like button. You could always comment or share or subscribe to the channel. And otherwise, I'm going to leave it at that, guys. I will catch you in part 3 of this very exciting series that I know you can't wait to see the next part of. Bye.